If you want to make an AI VTuber, it has to be able to talk. Because it doesn't matter how cute or cool your avatar may be, no one is going to sit for hours watching a cat girl stare right back. So we've got to give it a voice, and I did just that. In fact, you've been listening to it this entire time. Hey there, Real Limit here. Or am I? I just spent 2 weeks of my life trying to learn about ways to make text-to-speech for my AI VTuber Discord bot abomination thing. And yeah, I'll admit, I was pretty indecisive and things were a lot more complicated than I thought.
That's right, it's the square hole.
But I've also been pretty busy moving to another country, and my computer exploded while editing this video. But if you're seeing this, it's safe to assume that I haven't died from stupidity, I think. Text-to-speech is nothing new. It's been a thing one way or another ever since 1968, though not in the form of Joe Biden talking heads, but rather from Vocaloids like Hatsune Miku to VTubers like Zentrea and like the first versions of Mother V3 AI. That's right, I'm talking about speech synthesis.
Narrator narrates all.
This here is actually the project that led me down this rabbit hole of making Project J.A.I.son to begin with. Originally, J.A.I.son was an inside joke where I had to talk with Discord TTS because I didn't have a microphone. And I would always use the default Windows TTS voices, but at some point I thought it would be kind of funny if everybody could try talking using a TTS that had my voice. And so I thought, given how old this tech is, it wouldn't be hard to find out how to make a custom synthesized voice of myself. Oh no. This was a little over a year ago, and I've been going back and forth and looking into it, but every time I look at it, I remember something. I'm a fucking idiot.
Stupid.
So I spent a year looking into how to make one, and though I've never actually implemented one, I can tell you kind of how it works.
Hi, I'm David, and it's pretty obvious that
No normal human sounds like this. The speech that you hear being produced isn't individual words being stitched together from a recording of some poor soul that had to read the entire Oxford Dictionary. That method would need recordings for every single word with every single possible intonation, and it still wouldn't account for misspelled words, for example. Instead, it makes use of carefully crafted algorithms to generate digital sound that approximates roughly the pronunciation and intonation of phonemes. Now you may be asking, Limit, what the fuck are phonemes? Well, I'm glad you asked. Well, you see, the natural language can be broken down in a more meaningful way than just words and letters. Syntax refers to something akin to a sentence. It's a sensible concept or thought formed by a group of morphemes. Morphemes are the smallest unit of meaning within a word. The word running can be broken down into the morphemes run, the action, and ing, the present tense. But morphemes consist of phonemes, which are like syllables, the smallest unit of sound that makes a meaningful difference in the way we perceive words. Something like m or k can make the difference between mat and cat. So, phonemes are effectively syllables, or units of sound used to build all words in a language with intonations. Phonemes are language specific, so you don't tend to see text-to-speech voices in this manner that support multiple languages. When you give your text to a program, it breaks the sentence and words and whatnot into a series of phonemes, which may include information about the tone and the actual syllable that is supposed to be produced by the synthesizer. And it takes this series of phonemes and feeds it into a text-to-speech synthesizer. These synthesizers go down a list of phonemes and bippity boopity, here's your sound that it was programmed to generate per phoneme. This sound generating magic algorithm can differ, and the secret sauce used to make it can make the difference between this
Hi, I'm Alan.
to this.
Hi, I'm Brian.
But that secret sauce is, well, a secret, and something only really done by natural language researchers who are studying how to make these sounds in the first place. And that's why it's so hard to build a custom synthesized voice. It's still a relatively untapped field of research, and some of the crude robotic sounding voices that you may typically hear are actually made by university professors and researchers. So there's not much hope for a scrub like me to make something that sounds better than this.
and yet, Limit thought he could make a synthesizer.
Going for hours trying in vain to even get started with this shit. I was so confident and all like, oh, it's been over a year looking into this. I'm a better programmer now. Afternoon project, for real, for real. I can't even get TTS working for WSL2. Like, fuck, man. So different OS have different, I don't know what you call them, programs, interfaces, whatever, for text-to-speech. Windows has their own speech API, and it's aptly named SAPI 5 right now. And it comes built into your Windows machine. They got docs on how to use it and build with it, but I tried to look at it and then I remembered I'm borderline dyslexic. I also tried looking around for people who've done it before, and while no one has announced how to implement that shit, and McVoice is not one of those options, McVoice is different. So I said, fuck it. Where's the nearest open source I can be inspired by? Well, say hello to SpeakNG, Linux's way of doing text-to-speech. Normally running this command will allow you to generate speech using one of their pre-installed voices. The only problem is that WSL is different. In case you didn't know, WSL is Linux running on Windows, so Windows is still the main OS. WSL doesn't have support for playing audio from your Linux system through your Windows devices because it's living in its own little fake reality, given only the information Windows allows it. And for some reason, the audio device is something that WSL does not have access to. So it'll complain no audio devices exist, and such, no audio is played. I didn't realize that until I wasted some hours compiling and troubleshooting several dependencies from source. But at that point, I wasn't even trying to look into the code base to see how it's done. I just wanted to see if it works and hear how bad it sounds. So I eventually gave up and switched to trying to get it to work on Windows, and I wanted to specifically get Mbrola, or I'm not sure how you say it, Mbrola? Voices working because they have docs I may be able to follow to make my own voice, but I never actually read it, so I don't know. And man, was that a waste of time too. Some of the dependencies to set up voices have outdated URLs, so you have to download them from some archives and do some funny setup stuff. Then using this ancient UI, I couldn't just add one, set it as the default and work with it because for some reason it kept clearing and forgetting whenever I hit apply. Well, after bashing my head on it repeatedly hoping for a different result, I got it to work by scanning the directory containing all the voice files, then selecting a default voice. And now I'm taken to an interface I can put my text in to hear the results. But this is just a synthesizer. It's not doing any of the text parsing from words to phonemes. Thankfully, they have some examples in this Mbrola Voices database. So I took some examples there and slapped them into the input.
This is produced by the J.A.I.son module.
And it sounds like absolute shit. At that point, I gave up on trying to make a custom text-to-speech because I already knew nobody was doing this shit. You'd be a complete dumbass even to try doing this shit for something like an AI VTuber. But before I moved on from speech synthesis, I wanted to try something that I had also heard other AI VTuber devs use called VoiceVox. I thought maybe they used it to make their own voices, and after doing some research, it seems to be a Japanese text-to-speech software for Vocaloids or something similar. Their program is also open source, except for the actual voices, and they support the creation of custom voices if you can figure out how to make them. But it seems pretty clear that it's entirely in Japanese. And by some miracle, I also managed to check to see if it has the slightest chance that they may have some English speaking capabilities, but that was a little too optimistic. Also, with no knowledge of Rust or speech synthesis technology in general, looking into the code base went way over my head, so I guess I'll leave that for a later date. Okay, so maybe that wasn't a viable solution for a layman like me, but there is a way to make custom voices without the need for a major in natural linguistics. I already knew making a custom speech synthesizer would be the least practical solution, so before I even tried that, I already tried a different method. AI text-to-speech. AI text-to-speech may be slower, it may be more expensive, but damn is the quality of generation scarily good. So good in fact that I need to make a disclaimer. Despite seeming like an AI bro with this channel, I actually don't like the idea of stealing someone's likeness or even creative likeness, especially commercially. Hence the reason why a lot of what I've been doing so far has been based off of myself and data that I collect from myself. So you're probably never going to see me get into AI art or train with voices from other people other than my own. Okay, yeah, disclaimer over. AI text-to-speech entered the party a little later than its text-to-text counterparts, and it's only recently that third parties such as OpenAI have given us the ability to use text-to-speech models.
Today is a wonderful day to build something people love.
We have a limited selection of voices and currently don't have a way to train our own voices, so we can't use them for a direct approach. But once again, we can run it locally. I for one am not well versed with AI text-to-speech models, so I could only hope fine-tuning is as simple as giving it an audio file with a transcript. But on Hugging Face, I found two models that I wanted to try, XTTS and Bark. XTTS is specifically for voice cloning, and it is the most popular one used today. However, Bark is a little different in that it is a text-to-sound model that also happens to work for speech. And given its text-to-sound foundation, it has a unique property of being able to generate sounds like laughter and music at the cost of being a little less consistent. I wanted to try using XTTS, but it failed to resolve dependencies after running it overnight. Thank God though I had the foresight for once to predict that this may happen. So I made a separate project and downloaded the TTS library without all of my other project dependencies. And thankfully that one finished, but holy moly, look at all those dependencies. Even if this does work, I don't think I'll be using it inside of my project, especially because the license doesn't allow commercial use, which differs from my license. But I'm still gonna test it out because I've already sunk this much time into installing it. So I tested various models from the multilingual to simply English versions, and none of them produced consistent results with my voice.
Hello world. This is J.A.I.son speaking. 어제인 at Starlight on Trinity Days. I'm speaking. Output Aptray.
Hello world. This is J.A.I.son speaking.
In fact, it doesn't even sound like it even tried to clone my voice, so I don't even know if I did it correctly. As for Bark, it also happened to be in the TTS library, but for some reason my OS was acting weird, so I couldn't really try it through my code. So instead I tried their online demo, and the results were interesting.
Hello, my name is Sulu, and I like pizza.
Well, everything so far hasn't really given me the results that I wanted, and it seems like I'm nowhere near making a custom voice for my AI. But wait, there's one last option. I already knew that none of these options were what Vidal did for Neurosama, so why did I even try them? I don't know, cause why not? But there is an option that can run locally, fast, and efficiently, all while giving good results. An option that can even make you sound like a cat girl. AI voice changers. On top of synthesized speech, AI generated speech, and even real speech, we can use vocoders to change how the final result sounds. And much like speech synthesis, vocoders are nothing new. That's right, we're no longer looking into text-to-speech, but rather speech-to-speech. The idea is to use the better results from the previous attempts like OpenAI and speech synthesis to generate a base audio file with the speech, and then throw that through a vocoder to hopefully change it into our custom voice. And with the power of AI, we should be able to make an AI vocoder, which will be flexible enough to process any voice into something indistinguishable from my own. This was something that I had tried a year ago for the original project J.A.I.son, but I was attempting to use voice.ai and Balabuka. Even with an hour of voice recording data, the results were kind of abysmal. But AI vocoder technology has come a long way since then, and I think I'll have better results if I'm not running it over the internet, but instead right here on my computer. And after some digging around, I found the retrieval-based voice conversion project. This shit is gold made by the Chinese. Kind of like VoiceVox, it's mostly in Chinese, but thankfully you can find a translation of their docs in this docs folder. Basically what this is a voice changer that you can run locally and allows you to not only train an AI vocoder, but it also allows you to convert speech from WAV files and convert your voice in real time. All of this while having a UI so no code is necessary. Plus they use a package called Gradio to serve up the web UI. And Gradio's web UI also doubles as a web server that I can call from any other project using the Gradio client and get results without having to be inspired by their code. Setup was pretty quick, especially after noticing that they have this run script here. This run script basically does all the setup for you. And training is pretty simple after you've trained your first model and gotten used to the procedure. I spent several hours bashing my head though, because it's a little hard to see what's going wrong and what's going right. But let me save you the headache and tell you what worked for me. So on my 3070 with 8GB of VRAM, I trained a V1 model, not V2. A V1 model with pitch using a sample rate of 40,000 Hz. I used a 20-minute voiceover from my last video as my training data, and I processed it using RMVPE and RMVPE GPU. Each one of these processing steps will produce a statement similar to the one in the following. Once you see this, you know that it's completed processing. You can also find all the inputs inside the console you ran the web UI from. But for the most important part, come down to the final training panel. You can keep it as default, but I would recommend changing the batch size to 1 and make sure caching is disabled. For me, it would complain CUDAs out of memory, meaning my GPU did not have enough memory to run the training to completion. That's if I increase my batch size or use data caching. If you are still running into errors with memory, I would also suggest changing these D and G models to the non-F0 versions. Now, in order to start training, just hit this train model button and wait a couple of minutes. This confused me a lot in the beginning and wasted several hours for me because it will show an error in the UI and nothing will appear in the console. So I assumed that that button was just broken and I instinctively pressed train index model, which made it look like it was working for me. However, this was just a coincidence since the train model button takes a little bit before it actually kicks into action and actually start training, while train index model is the one that's actually broken. However, after an hour or so, your model will be done training and you'll get this .pth file, which is your model. The name of it is the name that you gave it at the top and it's what you use when referring to it in the future. This took me several hours of trial and error before I finally figured this out. And oh my god, I saw the CUDA out of memory error so many times that I went out of my way to spend all my savings on a 4070. Yes, it's that serious. But after I trained my first model with pitch, I gave it a try with speech produced by both OpenAI's TTS and speech produced by Balabuka. The fitness graph pacer test is a multi-stage aerobic capacity test. Hello there, my name is Jason. I am not one of the Ivona voices. That sounds perfect. And I didn't intend for this at first, but because I trained with pitch in mind, I thought maybe I could also make it sing. It's pretty convenient that they also have the ability to split main vocals from pretty much the rest of the music using their web UI as well. And so by splitting the main vocals from the rest of the music, giving the main vocals to my AI vocoder, and then overlaying the new converted main vocals on top of the rest of the music, I was able to make a cover in like 5 minutes. Now we have everything we need to make our AI speak, and all that's left is to put it all into Discord. I started with the text-to-speech models. Just like the text-to-text models from last video, I made a base abstract class and implemented specific classes for both OpenAI and a speech synthesizer using an interface library called PyTTS-X3. This library uses your OS's default text-to-speech, so it will be SAPI 5 for Windows or eSpeak for Linux, for example. I tested them out and checked out the results by manually feeding the outputs into the vocoder, and the OpenAI voice sounded pretty good after changing up the voice a little, but the synthesized voices were too robotic and the converted voice came out slow German. Oh well, nothing we can really do there. None of the other voices were that much different, and it's pretty much just an eSpeak specific issue. You'll get much better results if you use SAPI 5 on Windows, for example, or find a way to install third-party voices onto eSpeak. As for calling the vocoder web server from my bot, I ran into a roadblock. You see, I wanted to use the Gradio client when running the web UI and call that when the web UI app is running in a different process. That way I can keep this project lean and leave the maintenance to the core developers. However, there's a problem with trying to call the endpoint where for some reason I'm not allowed to pass none to this optional parameter, as a Gradio client requires this field to be a valid file path. However, if I do choose a file path, it would break if it's an empty mock file, and so I would need an actual F0 file, whatever that is, which I don't want to supply either because that would change how the vocoder behaves. So I sat there twiddling my thumbs thinking of what I should do. If I take the code from their repo and include it in mine, you would have so many more dependencies just for this one project. I'm not sure what base assets are required from the original to include in my own, and I would be responsible for updating the pipeline with new changes. And you would still need to download the RVC project to train your own models. So I kept cycling in this stage of denial, going between looking into copying their code to trying Gradio clients again. But after a couple hours, I finally cracked and decided to contribute to their open source. Usually I wouldn't because I'm scared of wasting people's time and merging my shitty contributions, but I figured there's no harm in trying, especially since this is a bit of a fix to what seems like unintended behavior. So I tested to see what changes I would need to make to support the optionality, and Gradio Client was stopping me from even making the request to the server until I filled out the field with a valid file path. And I did not want to add support for optional fields to Gradio because a lot of other projects depend on Gradio and I don't want to be the one responsible for breaking every single one of them out there. But to get around this, I decided to allow an empty file path to act as a mock, which will be treated the same as though none had been passed, ultimately skipping the F0 file processing. These changes seemed to work, so I forked their repo, made my changes again, and made a pull request following their contribution guidelines. The pull request is still up there right now, so we'll see if it gets merged. But for now, I'll be linking to my own fork so that you have the changes needed to run with my project. Once those changes were in place, the rest was simple. I just made the AI speech converter class directly. It will properly configure the Gradio server to use your specified voice. Then it will take the file outputted by the text-to-speech models and send that to the server to be processed before copying the result over, since everything's running on the same file system. I'm using default parameters found in the UI as well as an empty mock file. With that complete, I composed the text-to-speech and speech converter into a single class, so we have a singular entry point to the whole text-to-speech pipeline. I also did some cleanup since we were starting to pile up on command line arguments, and it was getting kind of annoying to have to type in my configuration every single time. So I replaced the command line arguments with some config files. Then I finally added the pipeline to my bot and got rid of the play sound command. I spent a while testing and messing up my async awaits since I didn't know what I needed to turn into a promise and whatnot with these libraries. But then I finally did it. And so there you have it. J.A.I.son can now speak. And now we're one step closer to a dead internet. As always, the code for everything that I did will be in the description below. Like if you liked the video, comment with what I could improve on. I'll be giving my AI the ability to listen and converse entirely through speech in the next video, so subscribe to stay tuned with that. But anyways, I'll get up and out of your way. See you next time.